Hi everyone, welcome back to our course in trigonometry. In this video we are going to work on solving an applied problem that will lead us to using the law of cosines. Okay, so in this example we were talking about two planes. They take off at the same time. One is at a heading of 135 degrees traveling 246 miles per hour. The other a heading of 175 degrees, traveling 375 miles per hour. The question is asking us, how far apart are they after 2 hours? All right, so I'm going to start out by drawing myself a nice picture here. Okay, now this isn't the XY plane, this is a compass. That's north, that's east. Okay, so a heading of 135 degrees is going to take us over into this region here. Okay. (135 degrees). Okay, remember heading is a little bit different than the angle in standard position business. We talked about this quite a while back, so I'm just going to remind you of how this works here. Okay, so that's the 135 degrees right there. Now the second plane is heading at a course of 175 degrees. So this is going to take me way over here. So there's the 135 degree angle. This is the 175 degree angle. Okay, so this is our picture right now. And the question is, what is this distance between the two planes? So let's think about what we know. One plane is heading out at 246 miles per hour. The planes have been traveling for 2 hours. So if you're going 246 miles an hour, you travel for 2 hours. Excuse me, you're at 492 miles traveled. That's your distance. Okay, so we can figure out how far this plane has traveled. So that tells us the length of this leg. 375 miles per hour. The other plane is traveling 375 miles per hour. If that plane travels for 2 hours at this speed, it will cover 750 miles, right? We double 357 because each hour that goes by, you cover 375 miles. So first hour you cover 375, second hour you cover another 375 for a total of 750 miles. Okay, so let me kind of clean up my picture a little bit here. Okay, so I think we decided this one was 750 miles. And let me see, 246, take 246 and double it, 492. This leg is 492 miles. The question we're trying to ask, the question we're trying to answer is, what is this distance? But we know this angle, okay? This angle is 40 degrees. Okay, where am I getting the 40? Well, one plane was at a heading of 135 degrees. This plane was at a heading of 175 degrees. So there's a 40 degree difference in the direction that these planes are headed. Okay, so I got side, angle, side. I can bring in the law of cosines to help me find this side length. Okay, we'll just call this x. Okay, so using the law of cosines, we see that x squared would be equal to this squared plus this squared. Minus 2, and then the product of these two, 2 times 750 times 492 times cosine 40 degrees. We don't need this part of the picture anymore. So let's get rid of it. All right, well now it's just a matter of crunching the numbers and then taking the square root. Okay, the numbers are going to be big, but who cares? We're going to be doing that on our calculator. 750 squared plus 495. 492, sorry. Okay, 492. So 750 squared plus 492 squared minus 2 times 750 times 492 times the cosine of 40 degrees, making sure my calculator's in degree mode. Okay, so I'm getting kind of a gigantic number here. 241,521. Now remember, I've got to take the square root of that to actually get the length x. So on my calculator, I will have it take the square root of the answer that it just gave me, and I'm getting 491. Okay, so approximately 491 miles apart. So a neat little application of the law of cosines. Okay, we can't use right triangle trig because this isn't a right triangle. Okay, we don't know these two angles, so that won't help us. The law of cosines will help us. So any type of situation where we can model things using a triangle, we can get that extra information. Sometimes we can just rely on the right triangle trigonometry that we did earlier in the course. If we don't know that we're dealing with a right triangle, we can use either the law of sines, or in this case, the law of cosines to help us get that extra information.